Lesson 7.4 is going to kick off the second half of Unit 7. And if you noticed, in the first half, we focused on an introduction to polynomials and then addition, subtraction, and multiplication. And in this one, we're going to kick off by doing the last operation that we hadn't worked with yet, which was division. So this is all about polynomial division. And there's essentially two types. If you're dividing by just a single term, a monomial, it's a pretty simple process, so we'll do a few examples like that, and then we'll dedicate the rest of our time to talking about what happens if we have to divide by a binomial or larger polynomial. Okay, so let's get started right away. If in your division problem, so just to recall, these guys are polynomials, they've got numbers, some of them have variables, all of our powers are positive. And it doesn't matter how long the first one, if you're dividing by a monomial, by a single term, okay, then it's really essentially still distribution, okay? So division of polynomial is completed by dividing each of the terms in the first polynomial by the monomial you're dividing by. And then you basically simplify. And there's one already worked out for you. So if we have this polynomial divided by 3x, we can essentially distribute that and make sure that we divide the first term by 3x, the second term by 3x, and the third. And then once we've set that up, we just simplify each one of those, remembering that the coefficients will divide like normal numbers. So 24 divided by 3 is 8. But that when we have variables involving exponents, we'll subtract those exponents to find out what our result is. And all of that is review. So I'm going to zoom in here just a little bit so you can see it. So let's try it, for example, on number 1. If we've got 48x minus 16, and I'm dividing that by 8, that is still a monomial, even if it's just a number. Then, like I said, it's essentially, you can think of that as distributing that division, just like you would distribute multiplication if you had a term outside of the parentheses. Division works the same way. So the way that we're going to solve this is we're going to take that 48x and divide it by 8. And we're also going to take that 16 and divide it by 8. And the subtraction sign in the middle is still going to be there. So we distribute the division. We make sure that both terms are divided by 8. And then we just simplify each one of those. So we know that 48 divided by 8 is 6. And there was only one x term there, so it comes down. It didn't have to subtract or change. And then we still have our minus sign. And then 16 divided by 8 is 2, and that comes out nice and clean, thankfully. And so this is a result. This is the quotient, or the result of that division. So when the divisor is a monomial, you can just distribute it. Let's try it again with number 2 here. We've got 9x squared plus 15. So 9x squared plus 15x. And if I want to divide that entire polynomial by negative 3x, then I just need to make sure that I distribute that and that the first term is divided by negative 3x and the second term is divided by negative 3x. And then I simplify each one of those separately. So this first one, 9 divided by negative 3 is going to stay a negative 3. And then x to the second divided by an x. I'm going to subtract those exponents. Remember, this has a little 1 there if we don't see it. And so 2 minus 1 is just 1, or x to the first. In this one, 15 divided by negative 3 is a negative 5. So this is now going to be a negative 5 here. And then x divided by itself cancels, so we're really just left with the 5. Or you could think of it like I said with the subtraction, these have a 1, so if I do 1 minus 1, it's 0, and x to the 0 just is 1. So it can go away, and this is our result. Okay. Go ahead and pause the video, try number 3, and if you feel good about it, then we'll move on to the more intricate division. All right, so hopefully you gave that a shot. Let's see. If you set it up correctly, this should be what your work looks like. You make sure you distribute the 6x and you divide both sides. And then your first term should have ended up being a negative 2x, and the second term would have just been a positive 3. 18 divided by 6 is 3, and x divided by itself, it cancels out. So this would be your quotient or your result. So when you're dividing by a monomial, fairly simple. Just like multiplying by a monomial was easy at the beginning. We used to be really comfortable with distributing that. And then we found out that when we were multiplying by more than just a monomial, we had to do more steps like FOIL or the box method. Well, something very similar is going to happen here once we start to divide by something larger than a monomial, whether it's binomial or bigger. Okay, so you have a step-by-step guide, but here's the deal. This is really going to be just long division. So how easy or hard this is kind of going to depend on how strong your long division skills are. And in fact, you may want to just take a pause on this video and do a little review on long division. If you had to divide something like, for example, 385 divided by 4, and you had to do that the long division way that you used to back in elementary school, the steps that you do here are going to be practically identical to the work that we're about to do here. It's going to be long division. Okay, and so you write your dividend, which is your first what you're dividing. Make sure that it's in standard form. Okay, you're going to insert placeholders and actually put a little asterisk next to that, because that is one small thing that is different than with regular numbers, and so you want to make sure you don't miss that step. Okay, so you're going to insert placeholders with 0 coefficients if there's any missing powers. And what that means is this. The reason you didn't have to worry about this in elementary school is, let's say I give you a different example. Let's say I was dividing 407 by 6, for example. This was already done for me because we already had inserted, the way that we write our numbers, right, already inserts a 0 placeholder for any empty values. So like if I want the number 407, right, we have our 7 in the ones place, we don't have anything in the tens, and we automatically already write that 0 placeholder. But in polynomials, most of the time we just kind of skip from one to the next. So you're going to want to make sure you insert that 0 placeholder. So I'll give you an example looking ahead. Let's see if there's a good one around here in our examples, looking ahead into our notes. Like this guy right here, right? So if I notice right here, I have a degree 3, and then all of a sudden it goes to degree 0. There's not an x squared, and there's not an x term. So those terms that are in between, I would want to insert zeros for, very similarly to the way that we would put a 0 here to hold that spot. Okay, really important step. It was already automatically done for you when you did this with regular numbers in elementary school. You're going to want to make sure that you don't miss that step and that you do that. Otherwise, it's going to really affect your answer. Okay, and then once you have written it in standard form and make sure you filled in any gaps like that, you're going to perform long division on the polynomials just as you would with integers. Okay, and you're going to keep going until the degree of the remainder is less than degree of the divisor. In other words, the number here doesn't go into your answer. All of that is going to hopefully jog your memory once you either practice this long division and then we practice here. So let's go ahead and start with number 4, and you can see this in action. Okay, we are no longer, since this is larger than just a monomial, this is a lot more complex than just distribution. We actually have to set up the long division. So we are dividing 5x plus, that's our dividend, and that's being divided by x plus 1. Okay, now follow along with me. Once you get the hang of it, it won't be too bad, but the first few times you got to make sure you're listening so you understand what's going on. Okay, so for me to perform this division, here's what I'm going to focus on. It doesn't matter how many terms are on these polynomials. My focus is always going to be on the very first 2 terms right in here. Okay, so the very first thing I'm going to ask myself is, x times what would give me 5x? Okay, that's like saying how many times does x go into 5x? But with polynomials, I think it's a little easier to think about it as like, if I have an x here on the left, x times what number would give me 5x? And hopefully you answered 5, right? X times 5 would give me 5x. And you'd be right, and that's what we're going to write up here at top. So 5 is our first part of our answer here. Okay. And then these steps start to be exactly like what you're used to. Once you know that x times 5 is what gives us 5x, we write that up at the top. Now here's the only thing that's a little bit different. A minute ago, we ignored the 1 and the 4. We didn't worry about that when we were doing this first part. But now that I have picked my number, and we come down to multiply down like we normally would, we've got to make sure that we distribute that guy there. Okay, so when I start to do my little multiplication to figure out what I'm going to write underneath here, I'm going to do 5 times the x, and that's going to give me 5x. And then I'm also going to make sure that I do 5 times the 1, which is going to give me a positive 5. And then I'm going to draw my line. Okay, so 5 times x is 5x, 5 times 1 is 5. If you did that correctly, when you multiplied those first two things, you should get a match here, right? That's a really good indicator that you are on the right track. Okay. Now, the other thing that a lot of people forget is that after this step, we typically would subtract these quantities. Okay. And when I subtract this, I have to make sure I subtract all of the terms. So it's all about distributing that subtraction, and make sure now in this next step, make sure you subtract this and make sure you subtract that. So basically it changes those signs. Okay, and let's go ahead and combine straight down. So 5x minus 5x is 0. And like I said, if you did this correct, these two should be identical, and when you subtract, they really should always cancel. That's a really good sign, once again, that you did it correctly. Here, I'm going to get 4 and a negative 5. That's a negative 1. Okay. Now, look at this last line. Continue until the degree of the remainder is less than the degree of the divisor. That's where we are right now. The degree of this is 0. My divisor was degree 1. This is less. X can't go into negative 1, right? So I can't play this game again. I cannot go back in and do another loop, because if I ask myself x times what gives me negative 1, that doesn't work. That doesn't exist, okay? This is a higher degree than this guy. So I know I'm finished, and I know that this is my remainder, okay? So now let's talk about how we write our final answer. How many times does x plus 5 go into this? Well, it went in 5 times, and then there was a remainder of negative 1. And the way that we write that is we write that remainder over what we divided by. Just like you would with numbers. When we're dividing numbers, let's say that I'm doing this guy real quick, right? I say 6 does not go into 4, but 6 goes into 40 6 times. I do 6 times 6 is 36. I subtract that. I find the difference. I bring this guy down. And if this is large enough, then I do it again. So 6 does go into 47, so I can do this again. 6 goes into 47 7 times. 7 times 6 is 42. And then I find the difference, and I get a 5. Nothing else to bring down. Does 6 go into 5? No. And so what I'm doing in that last line is I'm saying, oh, okay, so then I'm finished here. The answer is it went in 67 times, and then I put my remainder over what I divided by, and I basically am leaving my answer as a mixed number. So in this little example that I just did, let's cross this out so it doesn't get too confusing. In this example that I did, just to kind of jog your long division mind, the result to dividing 407 by 6 is 67 and 5/6. That's how you leave it as a fraction, which, by the way, is way easier than decimals, starting to add decimals and zeros and keeping going and going and going. I've always told you how fractions are easier, and this is a great example of why. You don't have to keep going. Once you get to your remainder, you put it on top of what you divided by, and that is your fraction. That is your mixed number. Same thing is what's happening here. When I realize I can't, go another round because x doesn't go into -1, then I just write my remainder over my divisor. And I know it looks a little weird, but you're going to get used to it because now we're dealing with polynomials. This is our solution. It went in 5 times whole, and this is our remainder. So we're going to leave it like this. Now it says use polynomial division to divide. Determine whether the divisor divides evenly. If it divided evenly, there would be no remainder. And this does have a remainder. So no, it did not divide evenly. But other than that, this is our solution. There it is. Okay, so I went nice and slow on that one. Let's try another one. And then we'll maybe do a couple bigger ones. So again, I'm doing 12x minus 8. I'm dividing it by 3x minus 2. This is my dividend. That always goes, the first one's always the one that goes inside the house. That's a little bit of review there for you. And then we're dividing by 3x minus 2. And then I'm going to make sure that these are in standard form, and they are, and that I'm not missing any degrees. I'm not, I'm good. So I'm going to start. I'm going to look at just the first two terms, and I'm going to ask myself 3x times what gives me 12x? What would I multiply 3x by to get 12x? So think about that. The answer is 4. Okay, so I'm going to put a 4 right up here. And after I figure out, oh, it's going to be 4, now when I multiply it, I do make sure that I multiply it by both. Okay, so 4 times 3x is indeed 12x. That's a good sign, the fact that those match. 4 times negative 2 is negative 8. And then I come in and I subtract both of those, which basically changes both of those to the opposites. Okay, when I subtract 12x, these guys cancel. When I subtract a negative, it becomes positive, or plus 8. Okay, and these cancel. So I get a 0 remainder. There's no remainder here. This went in nice and evenly. So the answer is 4. And yes, this did divide, excuse me, evenly into that divisor. All right, so hopefully you're getting the groove of this. Let's step it up a notch. We're gonna just come over here and maybe try it with a trinomial. Okay, let's try number 7. So actually, let's try number 8. On number 8, the reason I wanna jump to that one, they're all good practice, is one of the things that stands out that I would want you to catch here is that polynomial is not in standard form. So you want to be careful with those things and check for them. These are not in order from highest to lowest degree, and that becomes really important when you're doing this division. So as I start to set up my division problem, I need to make sure that I reorganize my dividend so that that highest term, this is degree 2, and that's my highest one. So that negative 8x to the second power should be the first term. Then the positive 6x, and then the 14. Really important that those are in the right order. Okay, and I'm dividing that by 4x plus 3. Okay, so make sure you've set it up. Also make sure that there are no skipped degrees. So if this is degree 2, I should have a degree 2, and I should have a term for everything below that, but I do. I'm good there. So this is degree 2, this is degree 1, this is degree 0. So there were no empty, degrees there that I needed to fill in with zeros. We're okay with that. Okay, so let's start our game. We're going to start looking at just the first two terms and asking ourselves 4x times what would give us negative 8x squared. So this is a little bit more complex, so maybe let's just break it down and do the coefficients first, and then we'll do the variables. So let's look at the coefficients. 4 times what gives us negative 8? Think about that. 4 times what number gives us negative 8? The answer is negative 2. Okay, so I know there has to be a negative 2 in that term that I'm looking for, because that's the only way I get this. And then let's talk about the variables. X times what gives me x to the second power? Well, the answer is x. X times x. Right, so it would have to be multiplying by another x for that to happen. So I know that that also has to have an x in it. Okay, so 4 times negative 2 is negative 8, and x times x is x to the second power. So this is looking good for me. Okay, and once I've decided that's what it is, I multiply it down to my divisor, making sure that I distribute it. And if I did that correctly, I should get a match here. So when I do negative 2x, times 4x, I should get the same thing that I had here. So negative 2 times 4 is indeed negative 8. That looks good. And x times x is x to the second power. So that is a very good sign. That means we picked the correct term up there. But we still have to also multiply it by the 3. So negative 2x times 3 is negative 6x. Okay, and we'll drop our line, and then really important step that sometimes people forget is that I have to subtract both of these things, which essentially is going to change our sign. So when we subtract a negative here, it's going to become a positive, and when we subtract a negative, it's going to become a positive. So both of these signs end up changing before I end up combining. Okay, and then when I combine now, these guys cancel, which again is a good indicator that you're on the right track. Here we get 6x and another positive 6x's. That's actually going to add up, and it's going to be a total of 12x's. Okay, and then we'll bring down the next term, and if possible, we'll start again. So the question is, can I play this, kind of do this little loop one more time? Does 4x go into 12x? The answer is yes. See, this time, this is not too small. I can multiply 4x and get 12x. So I can and I should. I have to keep going. So we'll just start the cycle over again. 4x times what gives you 12x? Well, the answer to that is 3, a positive 3, in fact. Okay, so if I multiply 3 times 4x, I do indeed get 12x. But I also have to make sure I do 3 times 3, right? I got to distribute it. So 3 times 3 is going to give us a positive 9. Okay, drop my line, change my signs because I'm subtracting, and combine straight down. These guys will cancel. That, again, that's another good sign. And here, positive 14 and negative 9 leaves me with a 5. Okay. Now, not only is there nothing else to bring down, but this is a degree 1, that's a degree 0. 4x does not go into 5. There's nothing I can't just say, oh, 4x times what would give me 5? That doesn't work, right? Because this is too high a degree. So I know I'm finished. I know that our quotient here is negative 12, I'm sorry, not negative, negative 2x plus 3, and then it has a remainder of, and then I just put my remainder over what I originally divided by. And that is the solution to this division problem. Pretty awesome, huh? Okay, let's try an example with a little bit of geometry in it. It's good, gives you somewhat of a glimpse of when this is applicable. Okay, it says write an expression that represents the length of the figure. So let's try number 11. We've got this area, and we know one of the dimensions but not the other. So we're trying to find out what this dimension, what this polynomial would have been. But this is a rectangle, so to remind you, okay, area of a rectangle is always the length times the width. And so if I want to find that length, I would have to divide both sides by W, right? So it turns out that to find the length, I would need to take the area and divide it by the width. Whatever that quotient is, that would tell me what the length is. So that's exactly what we're going to do. We're going to take this area and divide it by the width, okay? And we'll use the skills we just learned for long division. Our area is 8x squared plus 2x minus 15, and we're dividing by the width, which is 4x minus 5. Okay, I'm going to start to speed up the process just a tiny bit. You can always pause, rewind, but I'm going to start with my first two terms. 4x times what gives me 8x squared? Well, 4 times 2 gives me 8, so I know there has to be a 2. And x times x gives me x squared, so I know there has to be an x. So I'm thinking my number is 2x, or my term is 2x. Okay, then we distribute as we multiply that down. Okay, so 2x times 4x is indeed 8x to the second. But 2x times negative 5 also gives me a negative 10x. Okay. Then I change my signs through subtraction before I combine. These first two terms cancel. And then here I end up with 12x. Bring my negative 15 down. And I realize that I can do this again because 4x does go into 12x. And in fact, it goes in 3 times. I know that if I do 4x times 3, I get 12x. So here I go ahead and write my 3. I distribute it down. So 3 times 4x is 12x. And 3 times a negative 5 is a negative 15. Through subtraction, I switch both signs. Okay, so this cancels, which it should, and this cancels, which is fine because yeah, we probably expect this to go in evenly since that area was the product of the two. There probably wouldn't be a remainder. So sure enough. So what was our length? Our length was 2x plus 3. That's our answer here. So 2x plus 3. That must have been our length here. That's what we get if we divide the area by the width, we get that length. So there you go. And you could test it, right? You could use 2x plus 3 and 4x minus 5, do a little FOIL or box method and basically FOIL that out and multiply it, and you should end up with that area right there. Okay. I am not going to do 12, but I'm going to set it up so you kind of see, since that is a three-dimensional figure. So the idea here is we're now looking at volume, right? 3 dimensions, and we know that volume is the result of the length times the width times the height. So again, if I'm looking for the length, I would have to divide both sides by not just the width, but also the height. So by both of those. That way they both cancel. I would divide both of those. So it turns out that to find the length here, I'm going to do the volume divided by whatever the product of W and H are, which is width and height. So let's identify. Our width is 3 and our height is x minus 2. So what I would want to do is find that right there first and say, okay, what's 3 times x minus 2? That would be 3x minus 6. That's what I would want to divide by, that product. So now I could take my volume, 9x to the second plus 3x minus 42. And I would then take that whole thing and divide it by this, which is the width and the height multiplied together. And then I would go through the steps and do my division to find the length. So this time, since it's 3 dimensions, I wouldn't just divide by the width, but I would divide by that product of width and height. Try that one. Go ahead and use that one as an example to try on your own. See if you can get that length. So check your work and see if you were able to get the correct length. Dividing the volume by this product gives you a result of 3x plus 7. That's what I got here with 0 remainder, which makes sense in these problems. So that was the length. Our length for our cube here, or cubic, not a cubic really, a rectangular prism, is 3x plus 7. And if you didn't quite get this, look at the work and see if you can find where maybe you might have made a small mistake. So let's finish off. I don't want to make this lesson too long, but I want you to have enough examples so that you feel comfortable. So I'm going to hop down to number 16. There's a few here that I'm skipping that you can use as practice and or we can talk about in class. Be careful, make sure that they're in the right order. We start to kind of push the envelope a little bit with that, and make sure that there's no 0 placeholders that are necessary. So take a look at 16. That's the reason I want to do this one in particular. Right off the bat, that's what really jumps out at me here, is I have a degree 3 and then it skips down to a constant. So there's some stuff in the middle here that I want to make sure I put a 0 in. This is what that's going to look like. Okay, when I start writing this dividend, I'm going to say, okay, x to the third. And then if I don't have an x to the second, I'm just going to write, literally I'm going to write 0 again. If I don't have a regular x term, I'm going to write 0x. That's how you write your placeholders. And then I do have a constant of negative 20, so I can leave that there. So there's those 0 placeholders between the degree 3 and the constant. I just put a 0, and then I still put the variable and degree so I can keep track. And you're going to see in a moment why this is so important. Okay. So now that I have it in standard form, so we're ready to go here. That's being divided by x minus 3. Let's go ahead and start playing this game. We'll look at just the first terms here at the beginning. X times what gives me x to the third? So what would I multiply x by to get x to the third power? If you think about that for a moment, hopefully you agree that it would be x to the second. Since our exponents get added when we're multiplying variables, this is like having an x to the first, so 2 or more of those give me x to the third. So it's going to be an x squared, okay? And then we'll distribute that down, okay? x squared times x is indeed x to the third. That was the whole point of that. And then look what happens here. X squared times negative 3 is a negative 3x squared, or x to the second. This is why I needed this spot, okay? Because I need that to be able to line up there. So when I do negative 3x times x to the second, I get negative 3x to the second. And because I was so smart and awesome and I put my placeholders, there is the like terms, you know, holding that spot ready to be combined. So there you go. I drop my line. Make sure you change your signs before you proceed, because that subtraction is going to change those signs. These guys are just going to zero out. That's important. That should happen. And then 0 and a 3 is still a 3. So I still have 3x to the second. 0 plus 3 is 3. Okay, so that just basically comes straight down. I bring down the next term, and I see if I can play my game all over again. Does x go into 3x squared? Absolutely, right? So we'll do this again. X times what gives us 3x to the second? Well, the answer to that is a positive 3 and x, right? So if I have 3x times x, I will get 3x to the second power. So I think that is definitely the correct term there. We make sure we distribute it as we come down. So 3x times x, 3x to the second. 3x times negative 3 is negative 9x. Okay. I drop my line, I change my signs, and then I combine straight down. That lets these guys cancel, and 0 plus 9x is still 9x. And we bring down our next number, and we ask ourselves, can we do this again? Can x go into 9x? The answer is yes, we can do this one more time at least, yeah? So x times what gives us 9x? The answer to that is 9. So I write that right next to it. And I distribute it down. You can see the cycle just starts over again. You guys knew how to do that way back when you did long division, is exactly what we're doing now. So 9 times x is 9x. 9 times negative 3 is a negative 27. Drop your line, change your signs, combine. These guys cancel out, as they should. Negative 20 and a positive 27 leaves me with just a positive 7. Here, does x go into a regular 7? No. This is now a smaller degree, and I can't make this go into this any further. I know that that is my stopping point. So that is my remainder. If I were to write my answer here, my answer is then x squared plus the 3x plus the 9. That's what we ended up. That's how many times it went evenly. And then my remainder is going to be that 7 over our divisor, the original number we divided by. And that's my remainder term. So I've got my polynomial and the remainder term. And that is the result. Okay. So we probably will maybe do one more together, but this is a good stopping point. Hopefully this gives you enough practice. Feel free to use a couple more of these as extra practice if you like.